So there's still more time to submit late, as the late policy. It's just a little brief overview of some scores I pulled in case anybody's interested. Pretty good. I was actually kind of impressed. So like 92 people got 100%. Then you can see it kind of go down. The average was 73, which is actually about not too bad. C average. So yeah. I don't know. Any high-level questions on this? Yeah. Oh, there's only 175 people submitted, so there's a lot of zeros that were on here. These are people who actually submitted once on the homework system. I think it's fair to count those people in the last 2 weeks if they submitted anything once to include them on here. So yeah, this was the grades that I pulled directly from the submission survey. Yeah. Louder, gotta be louder, guys. Highest score of all your submissions, including late submissions. Yes, whatever your highest score is. Yeah.
Can you repeat that? You said that's not the final score?
What?
Did you say that? Is our final score for this assignment? Like, the grade we got in the submission server, is that the grade we got?
For sure, yes. Yes. Yeah, the grade you got on the submission server is your grade. There's no partial grading, it's automated grading. What I meant is that you could have somebody who has, let's say, a 0 on here or 15, and if they do it all, finish it all today, they can get 80. So they can move their grade up to the most of 80. Highest grade. Whatever. All your submissions, highest grade. Yeah.
So on my best submission, I got everything except for one case. If I turn it in late and then got every case right, that would override like the
No. Highest grade overall. You can still play with it and submit until you get what looks to be 100. That'll count as 80, so your total grade will be 19. Cool. All right. Get started. Fun. All right. What's today, Tuesday? So on Thursday we were talking about access control. So what was the method? So we talked about using an access control, a matrix to represent access control rules. Somebody help us out, refresh us for those that were maybe putting off the homework until, well, the last-ish minute of Thursday and weren't here. Help refresh us about what is the access control matrix? Yeah. So you could have a chart or a table. Yeah, so what was on the, what were the rows of this table? Subjects. What are subjects? Things that can act. So things that can act in the system as rows, and then what about columns? Objects. What are objects?
Things that we acted on.
Things that subjects can act on. Yeah. Are subjects included in objects? Always? Maybe not necessarily, right? It depends on the specific system. So, cool. Okay, that's great. So, wow, you guys actually learned stuff. That's good. So we can represent our access control model in something like this, right? Rows, columns. So then how do we tell what rights user V has on file G? What rights does user V have on file G? And how do we figure that out? It's you now because you asked.
Well, I mean, they have no rights. We figure it out.
And how do you figure it out? That's the more important question, yeah.
Okay, so like user V, like you just trace it down to the left column.
Okay, so row, so we look at the row, we say V, okay, great, now what do we do?
And then we go to the like two columns down to G, and we see it's blank.
Cool. Yes. Awesome. Any questions on the matrix? So what are the benefits? Why do do we want, what's good about this model? What are the benefits and what are the drawbacks? Yeah.
If it's small, you can easily tell like who has access to what.
Yeah, so if it's small, we can easily reason just by looking at it exactly who has access to what. There's no extraneous rules that exist outside of the system. All the access control rules are there for us. Yeah. Yeah, so on the contrary, right? So by the same token, so that having, if it's small, it's easy to look at. If it's very large, it's probably difficult to reason about what things can do. Yeah. Cool. All right, and then we talked briefly a bit. So imagine you're going to implement this, and we'll focus specifically on operating systems a little bit now. So what does an operating system need to control access to? File system? Oh yeah, in what sense? So what? Yeah.
Memory?
Memory? So in what way? Can you explain?
What the user stores in there, such as maybe you want some stuff to remain private, other stuff easy and fast to access.
Yeah, so you have your memory, right? So each, let's say, memory region is owned by a different process. If those you don't want a process to be able to access the memory of another process until you do, maybe with some shared memory between them to make sharing stuff faster. So you couldn't want that, but you could also, by definitely, so you would not expect maybe you visit a web page in your browser. Would you expect the JavaScript that's running on that page to be able to access your Word document that you have open? No, that would be very bad, right? Yeah, so memory. What about files? What does the operating system want to control on files? Yeah.
You can read, write, or execute a file, maybe?
Yeah, who can read, write, or execute a file, but why? Why do we care?
Because sometimes those files might be pertinent to how the system operates. So like I changed it, and then now the system either doesn't operate or operates differently.
Yeah, so maybe to prevent people from breaking their own system. That's a good one. Yeah.
And also, if another process depends on the content, you want to keep everything separated.
Yeah, so I guess an interesting thing to think about is actually, do you care about this on your laptop right now? Does anybody have shared accounts on their laptop? Maybe they have somebody else with a different account on their laptop? Nobody? So you don't care if your apps are different, you can access or change different files on your laptop? It's up to you, I don't know. This is an opinion question, it's not a right or wrong question. Do you care about keeping, so we said maybe different users being able to control who has access to what, but if you have a device where you're the only person who has access to it, and there's only one user, why would you care about this? Yeah.
I think like, since, I mean, you're the only human being that has access to it at the moment, physically, but I mean, if you download something that like escalates privileges, then someone else might access all those files.
Right, so if you download some piece of garbage software, right, from the internet that's doing who knows what, that has full permissions as you, it can access and touch any file that you have access to, or any file on your machine if you don't have any restrictions. Yeah.
I was going to say, it kind of makes sense to limit it. So, in a way, I think an argument made that makes sense to have only one account for like one user account plus like an administrative root account on a personal machine because we're no longer working with terminals and mainframes anymore.
Right, okay, so yeah, so this is actually kind of interesting, right? This idea of having different users being able to access the system simultaneously and being able to do different things on the system, right? Kind of comes from the days of mainframes or other types of servers where you had multiple people logging into one system, so they were literally accessing it concurrently. What's different about how your desktop operating system works versus like your mobile phone? Specifically, we'll talk Android and iOS. Yeah.
It's broken out a lot, like a lot more security measures. So you have your fingerprint scanned, and you can also check your face check, and the computer, like for now, just seems like you just have a password that you can really input.
Yeah, so you can think about authentication, but specifically on access control. So what about all these apps that you're downloading? Yeah.
So you
Yeah, so one way to think about it, right, is there's actually a different layer, so we're talking about access control, right? There's this whole permission model on most phones about giving different applications different permissions. Yeah, what else? Yeah.
On most like Android or Apple devices, you don't have administrator access. You have like basic user access, whereas on your laptop you probably have administrator access.
Yeah, so you maybe don't even have admin or root access on your phone. You can, I think at least in Android, you can very easily create new Google accounts so people can log into your phone so you can share devices. And then, so each app on your phone actually executes as a different user. So essentially you can think at a rough level, both of the devices, Android and iOS, have some UNIX underpinnings underneath. And this is actually the big conceptual model and change that they did with moving to this app model, is rather than have every app run as your user, each app has its own user account on the system. So the permission model is actually enforced that way. So anyways, different ways of thinking about permissions, but now I want you to put your mind into somebody who's developing an operating system. You're going to develop an operating system, whatever one of these things. How do you implement an access control matrix in an operating system? And I'm not talking, this isn't a low-level, scary discussion about operating system internals, but I want you to conceptualize and think, okay, if I was tasked with doing this, how would I do it? Yeah.
I like start thinking about what are the types of people that are gonna need access to the system.
Okay, so you think about people who need some way to like create users or whatever, but more specifically, like how do you implement this access control matrix? Yeah.
I mean, like ignoring efficiency and whatnot.
Sure.
If you use that like table that we had before.
Yep.
Every time, like, let's say you have like a subject asking to do something, you just look it up in the table and then see if it has permissions to act on a certain object. And that's it.
Yeah. So okay, so we could then go back to our nice handy dandy table, right? How would you implement this? Yeah.
It wouldn't be like memory efficient, but a 2D array could work.
Hey, you could do a two-dimensional array, right? Or a two-dimensional hash table, however you want to think about it, right? So have subjects where you can map, let's say you can map subjects to numbers, right? And so you can use a two-dimensional array, and you can map all the objects also to numbers. So you keep that mapping separate. You look up what is the subject, look it up, access the array in one dimension, and then access in the other dimension to see what the set of permissions are, and then reject. So you have to have some way of thinking every request that's going to come into the operating system, right? You need some way to enforce this access control policy that's stored in this matrix. And then we'll need some ways to update it too, right? As we add users, add different kinds of things. Yeah.
Yeah, like I want to make sure that whatever file you're storing in it has the right permissions as well.
So yeah, we need a way to have user space programs access this matrix, right? And be able to interrogate it to say, have a user say, well, what permissions does that file have? Which is probably a better way than just attempting to do whatever you want to do and seeing if it fails or doesn't fail. So there's a lot of talk about ignoring efficiency. Why is that? You guys not care about efficiency? You just say, yeah, like every machine's have gigabytes of RAM now, so who cares about efficiency?
Well, yeah, the safety answer comes the fact that we have more processing power and stuff, but also maybe if efficient might be the best way, but sometimes you want to make it more secure, so you have a bunch of redundancies to make sure that no other person can access other stuff.
Yeah, so you need to definitely like check and verify and make sure that your implementation is secure. But let's say we're very good and conscious programmers, we know we can do it safely. And we've even considered the thing we haven't talked about, which I don't think you quite get to until operating systems, but concurrent access to this matrix, right? What happens there? So you need to make sure that you're thinking about concurrency, but we've thought of all of those problems. Yeah.
Well, I mean, the issue with the 2D array would be there's a lot of redundant elements because not every subject acts on every object. So you maybe could have like a graph of all the different subjects and objects, and like you can point with the rights to each other.
Cool, so maybe we can make, so does everybody kind of understand, like even in this diagram, right, we have 3 blank squares, right, where there's no rights to anything. There's all kinds of efficient data structures you can get into of sparse matrices, which they use in like numerical processing and all this stuff. So you can make it more complicated, right? You're getting away from this easy 2D model. Yeah.
This
basically the amount of data you would need to represent like this table be like n by n or n
Where
by
n is what? Yeah, what are n and m?
like users and files.
I mean, technically, definitely is n by m, right?
Yes.
Two different numbers. So it'd be the number of users and the number of files, right?
Yeah.
So what's that going to be on a system? It's going to be huge. Would you use an operating system that used a model like this? No? Yes? No? Why?
Too much space that I can't use.
Yeah, it's probably going to take up a lot of memory. I mean, you can do some back of the envelope calculations. And the worst thing is it's not even like a constant amount of space, right? It's going to be continually, as more and more files get created. So as you're running a program that's creating thousands or hundreds of files, now you're multiplying, adding more additional columns to this table. And the operating system has to do this for every access, right? Cool. So do we want a better way? Hopefully. So, then how do we get there? So you're all smart people. So it seems to be that the intuition would be like, okay, storing this huge array in one place seems like a bad idea. We can all kind of agree with that. So what's the alternative? Or what are some alternatives? We can just spitball different approaches. It doesn't have to be exactly where we're going. Yeah.
Attaching permissions to specific times.
Wait, okay, so just a second. Let's pause because I want to make another point. Okay, so this is the UNIX model. I don't know why I put that up, but cool. So can we just get rid of information? Would it be good if we just said, well, we'll simplify this. Let's keep the access control model, and we'll just stop the matrix at all of our subjects will be columns and the top 5 most frequently accessed files. Would I solve your efficiency problem? Yeah, it solves the efficiency problem. It's way efficient now, right? I've capped the size of this table. It's going to, be in maybe, I don't know, a couple kilobytes. What's the problem? You had a very visceral negative reaction. Yeah.
I mean, at that point, if you go, like, an unauthorized user could use something that they shouldn't be using.
Yeah, so we're getting rid of information, right? So the nice thing about this matrix model is it's storing all of the information about who can access what file on the system. And we've talked that even we can represent kind of simplified role-based models or other types of models in this system, but fundamentally all this information cannot go away, right? In the name of efficiency. If we just like started throwing away access control rules and said, whatever, it's like mostly everyone can access this file, right? That's probably not a good access control system. So then what can we do and change? Yeah.
Instead of talking about like accessing a specific file, accessing specific file types. So like this program can't access .exes, it can't access.
Okay, so we could do kind of abstractions, but that's similar to the role-based concept, right? We can abstract users into different roles. We can abstract objects into different types of objects. But we'll still, what if we have an app that just spits out, hundreds of thousands of different file type extensions, right? For every 3-letter domain or whatever. Or what about things that don't have file types, right? Yeah.
Maybe you could like make it almost like a lock and key sort of system
Okay.
where it's localized to each file and each, not user, but each program that does anything.
Okay, so let's
oh, sorry.
Oh yeah, no. Let's go with that first concept. So the idea is let's keep it localized to each file. So what would that mean? Yeah.
You put some sort of metadata on the files
That says what?
that tells you permissions for each user for that file.
Yeah. So rather than necessarily storing one giant table inside the operating system that must be maintained, what if we split this matrix up into columns for each file, and we store extra metadata with the file that says, here is the access control list of this file. Right, here are what users have what rights on this file. Yeah.
Doesn't the group permissions already do that? So you could just
same access rights on a file that we do in a process. What happens when the owner wants to change those permissions? Does it need to go to all the processes and update them and the file? Like there's complications there. So in general, duplicating these rules, it gets dicey, right? Because you can get into circumstances where they're not in sync of what they should be. But thinking about it in those two ways, so if we have to keep the data the same, right? We can't throw away any data necessarily. Well, the ways we can split this up, we can split it up into columns and put on each file or each object the rights that each user has. Or we could split it up into rows and have every user process, or every process has the list of permissions of what it can access for what file. So what are some of the pros and cons? What if we just threw, let's say this file F, we just throw some metadata at the top of the file that says U has R1, R2, and V has R2, R3. Yeah.
I think if we're comparing, like, are you comparing it to the other way around where every like process has a list of what it can access?
Nope. Just on its own, we're evaluating the merits of just a, we'll call that an access control list. So every file has an access control list. And we're adding that to the top of every file. Yeah.
You have to protect it because it's more localized to the user, so they could go and change the privileges more easy than if it was embedded in the operating system.
Yeah, so right, so if it's embedded in the operating system can protect it. So this is why maybe this naive idea of, well, we'll just throw it to the top of every file. Well, if the user can edit the file, if they can change their permissions, they effectively have complete access to that file. Yeah.
I mean, you're still using a lot of storage space, especially if there's a lot of users.
Yeah, we're maybe using additional storage space, right? So maybe we can think about that, but in some sense we can't get rid of it in this concept of being able to store this matrix. Like that data has to be somewhere, right? But who has access to what? Yeah.
Now it would be stored on disk rather than memory, so reading those permissions is significantly slower.
Yeah, so that's an interesting point. So disk is, actually I don't know the current term. Is it 1,000? 10,000 times slower than memory? I can't remember with SSDs that changed the number, but anyways, reading from disk is a lot slower, right? And so now you have every time a process wants to access a file, instead of having a quick lookup in memory from the operating system, you now have to read maybe a different file or something before you can read that file. So yeah, you're going to have performance hits for sure. Cool. So these are all things we need to think about. And so, and this is, so what does a system like, so these are UNIX permissions for a file. So what does like a Unix type OS do? Yeah.
It does this where it has for every file it has metadata you can access it.
Yeah, it kind of has this, although on the, as we'll get into, right, on the granularity of what the subjects are, it's not individual users, it groups users into 3 different categories, and then has permissions on those categories. But the fundamental model is adding it to the file. So there's special metadata in the file system that says these are the permissions of this file. So we talked about some downsides. Any other upsides? So what about, now let's think through, a new file is created. What has to happen now? Yeah.
You just slowly go through the entire hard drive and add it and all the privileges to every file that interacts with it.
A new file is created.
Oh, a new file.
A new object is created.
Mhm.
Do you have to touch every file in that case?
No, just all the subjects.
No, right? You have to update the well, okay, also no. But, so what happens? Let's step through this. So a new file is created. Yeah, it's back. So, say that again?
The default permissions that are set to the file created.
Yeah, okay, so a file gets created. Let's say there's some set of default permissions. Where do we store that? What happens? Yeah.
You go down to the metadata, put in default permissions as the policy dictates.
All right, let's go through this example. All right, I'm going to draw on this. This never ends really well, but let's try this. Back. So we create a new file H. So in the access control model, or in the matrix model, right, we create a new file H, which means we need to propagate, we change our matrix to support that. So now here we create a new file H, what do we have to do? So we need to assign permissions. Let's say there's some default permissions. We'll say, what are our subjects here in this example? P and Q. Okay, so we have P and Q. There'll be some default permissions or whatever. So let's say it's write, and we'll say this is read, and we'll call it own as well. Yeah, that's exactly what I wanted to say. Okay, so now then what do we do? How do we store this data or this information? Yeah.
Would we append it to the file?
Yeah, let's say we'll just store metadata with the file. We don't have to say, but it's in a protected way so that we know people can't tamper with it. But we'll just say it's metadata stored with the file. Do we have to touch files F and G?
No.
Why?
Because of their own systems.
Yeah, because they have actually nothing to do with the access of H. Right? So this is a nice thing about this model is by storing who can access what on the object itself, right? When you create a new object, you don't have to touch anything else in the system. Now we get to this problem of what happens if I add a new user, we'll call it A. What do I do?
Go through every object and decide what permissions you want to give.
Yeah, so I need to go through every object in the system, every single file in the system, and add that permission there. So I have to go, okay, F. What can A do with F? Well, A has read access to F for whatever reason, and G has read access, or A has read access to G. That's an R. And I have to go over here, and A has write access. Cool. So now every time I create a new subject, what do I have to do?
You have to append your entire.
I have to touch every single object in the system, right? I have to create this new object on every single access control list here. I don't know, good, bad? Yeah.
I was gonna say, so when you create a new user, you're just giving it like permissions. But say in the case that like the system decides that. But say if the user created the file, then it's like it's a more simple case because it's saying, hey, you created a file, so you should give these permissions. Like in that case, does that user also control the permissions of other users? In a system like that.
Say that so in general, so yeah, so here we don't really have any concept of owner or anything like that, right? So that's kind of in our concept of, okay, when file H is created, what are the permissions? Right, well it probably depends on who created that file. So I just made Q the owner of this file for no reason, just to have that be that, right? But yeah, so then similarly you need to think about what happens when you add a new subject and updating all these, yeah.
Why not make every user or program that connects to the user have a type, and that type comes with a certain associated set of permissions. So then when you go to the file, instead of listing what every single user can do with it, you say this type of user can do this type of user can do this type of user can do this. That way, when you add a program, you just add a type to that program or user that you've added, and then you don't have to go and add everything to every other file.
Yeah, okay, so we can think about then, this will be hopefully better. So we can think, okay, we can have types, right? So we can have file F, we can have file G, and type, what kind of type do you want to say this is? I don't know why, but I do know why because I've been reading a lot of code. So type C and type Java, right? So then I have my subjects S, and let's say I have Adam, who is a C programmer, and Max, who is a Java programmer. Something like this is what we're talking about, right?
Yeah.
Okay, so then what happens if, how do I give, so let's say there's Max, there's also Bob, who is a Java programmer, secret project that I really need Max's help on. How do I give Max access to a file? So let's say I have now a file secret, and it's mostly in C, but I really need Max's help, but it's so secret I don't want anyone else to know about it besides Max. Yeah.
Add it to a group.
Add into what group? C?
Yeah, so like.
But we have other C stuff that Max shouldn't be able to have access to.
But like that, it could be like not a group called C, but like a group called Secret Project.
Yeah, you have to make a group for the secret project. Yeah.
Well, see, here you can go back, I feel like here you can go back to the old implementation by adding just some sort of exception variable. So, like, in general, we want to stop there being continually every time you add a user or every time you add a file, you have to add massive amounts of information. So this generalizes it well, but then at the bottom of each file, you can add exception type of things. And adding just one exception here and there isn't going to break, like, the efficiency.
Yeah, so then we can do something like that. But so this is kind of the point was thinking through if you just have a simple model with, let's say, types or something, right? Can you actually express every possible access control model that you can in a matrix model? The answer is usually no. So you need other mechanisms to handle these cases. Yeah, and then you get almost as complicated as a matrix, and that's why thinking about it in terms of the matrix is nice because you have a way to think about that and how you implement it to use these tricks. Yes?
So if you didn't want to use types, you could still use the user model or using user metadata. Have some other, I guess, token that represents no permissions. So then the absence of permissions would just be like a default. And so then when they try to read it or write it, it would say, okay, there's no permissions set yet, get the default permissions.
Right, which would help unless my default permissions is everybody could read my file or something like that, right? So you can definitely think through these corner cases that can help out in some of these things. The idea is thinking about this more generally, but these are important things to think about when we think about, well, why is a certain access control system like this? And it's because of these performance reasons, right, of optimizing for different cases. Cool. Any questions on access control lists? Yeah.
So wait, so then what actually does happen if you add a new subject? You have to go through? Or
If you're just thinking classic access control lists, yes. You need to go and touch every file.
okay.
That's why modern systems, you can see the access control list is usually a group. Groups users together, right? There's the owner of the file, the group, and everyone else. So you don't have to update. You're either in one of those categories depending on which user you are per file. But then you can't, it's actually a real pain. If anybody has administered a UNIX system, it can be a very big pain to do things like this of like, do you create a new group just for some subset of users that need to have access to something? Like, because you don't have these fine-grained permissions of doing these kinds of things.
Thank you.
Cool. All right, so then the flip side is we said, okay, rather than thinking about it in terms of columns of what file can access what, now we can think of it in terms of who has rights, what subject has rights, and what do they have. So basically, rather than storing now the information with the file, each process has a set where each subject has what rights it has to every object in the system. So we'd have process P has the rights on file F of read, write, own, and group of read, and process Q has A on F and RO on P. So what are some of the benefits here? Yeah.
I guess in a way it's dynamic. It's not like you have to preset a certain amount, so it just grows as the user just grows.
Yeah, so it's kind of nice in some sense because we don't have to, and we can maybe assume that the number of users is less than the number of files, maybe significantly less. It's by default true if all the subjects are included in the object set, right? So yeah, we have a nice thing there. Maybe you said something about dynamic. What do you mean by that?
As in like, as opposed to like static, where I would say, okay, there's going to be 40 users, so there's going to be 40 capability lists. It's going to be like, as the amount of users grow, that's going to increase the amount of capability lists per user.
Yeah, okay, so yeah, so that as the number of users grow rather than the number of files is how big or complicated this list gets me. Other thoughts? I'm looking at all sides.
Okay.
You should be looking at all sides. I already know this stuff.
Okay. If we're assuming that there's less subjects than objects, then what happens in this situation? You have, how do I put this? You have like a very long, let's say it's an array, really long array. So like what happens is you have a lot of continuous memory being used. But like the other model you had, it's like all the memories like being like separated on the disk, so it's not all in one spot.
Right, and if we think, I mean, there's one way to think about it in terms of disk or file, right? But if we think that these users are actually a process, right? Usually you'd store that maybe in memory, you'd think, rather than necessarily on a file. I mean, storing access control list with the file on disk makes sense, right? It's literally storing it where the data is located. But here you have a process, and where does a process live? What even is a process? Right? It's like, well, actually maybe I should ask you that. What is a process?
Executing program.
Yeah, so maybe, so involved in that, right? So you have memory, so that the memory that the process has access to. An executing program, I mean, a process can be asleep, so it could not actually be running, but it has some state associated with it. Maybe it is running. So you have all this kind of complexity of where the heck you would put this list. Maybe you store it in the operating system. There's the operating system, if you ever have typed in PSAUX to list out all the processes that are running on your system, you'll see that there's a ton. So the operating system must know what's trying to run on your system. So it must have metadata there for each process. Maybe you could store it there. You know, all these kinds of choices. But there's not like a inherently nice thing of like, oh, store the access control list with the object. Other pros, cons of this approach? Thoughts, half thoughts?
Yeah, I was formulating it, but so I feel like with this method, since we create a lot more files and users, you have to constantly go through all the users and keep adding or appending to it.
Right.
Files.
Yeah, so now we go through, let's walk through maybe the same cases we just walked through. So we add a new file H. What do we have to do? Yeah.
Add the rights to each user.
Yeah, so we need to go to each of the capability lists of every subject and add, you're right, I'm just trying to be slightly more precise. Yeah, so we have to create a new file H. And now we have to go to P's access control list and the H has file. I don't even remember what I put. It was whatever, right? So we have to add a new thing to each of the capability lists every time a new file is accessed, right? Yeah.
And just to add to that,
Mhm.
it's continuous memory. If we run out one of the files, we have to copy everything over to a new spot in memory. That's slow.
Yeah, so if we're storing this in memory, right, we have the problem of having to deal with either contiguous or linked list or however we're going to do it. There's going to be problems or at least things to think about. Let's go a different way. What if we add a new subject atom that's going to run? What do we do? Yeah.
We have to see what files out of our processes, out of the entire system that each run.
So then I'll have some, we said some kind of default permissions, right? So the current files I have are F, G, and H. R, W, right? Did I have to touch any of the other capability lists? Should I have?
Yes, because you need to add X permissions and so on.
Yeah, so maybe. It depends on if my subjects are also objects, right? Because I may need to add those. But in this model here, where we're just using files and users, actually, I would have definitely had to do that. So that's a good point. So I'd have to go here and add something about this here. Yeah, so okay, so now we've looked at this. So compare this then to capability, to access control lists. Yeah.
I actually have a question.
Sure.
Why did we add like atom, the subject/object to like P and Q, but we didn't add P and Q to atom?
We would have had to, yeah, as well. Yeah, I just simplified.
So do we always assume that subjects can be objects, or is this a case-by-case thing?
Case by case. So it depends on the model.
In this case, we're assuming they're all.
Yeah, so in this case, I would just be going off of this access control matrix model, which is the example that we use. We need to include those on there. We can ignore it kind of for now, but conceptually, yeah, you need to think about those. Yeah.
So can you give us an example of when a subject is an object? I just can't really.
Sure. So you have two processes, whatever, P and Q, that are owned by different users. So they should never be able to share memory, right? You should never be able to access memory from the other. But you can, with a system call, you can ask for shared memory that's shared between them. So you can think of that as having access to write to the memory of another process. And that would be a write that you could have. Other things would be like sending signals, like being able to kill another process. Like normally you can't send a kill signal to another process, but I think you can set that up so you can, or if you're in the same group you can. There's all kinds of weird stuff, yeah.
Wouldn't like almost like plugins be an example of this? Like one bigger program, and then if you want to install a plugin, then that thing has to be able to act on the other program and affect it.
Yeah, plugins, that's a good one. The other thing that made me think of is like the Google Chrome browser model, where you have like rendering sub-processes. So you have different things rendering, then parsing HTML, then doing all this stuff. So they need to communicate somehow, but over a limited fashion. So that would be another way of thinking about that. IPC, so that's the other thing, like inter-process communication. Like a process can talk to another process, maybe through pipes or UNIX sockets or something like that would be another example. There's more than I realized, but yeah.
If we're like still on this, comparing it to what we had before, a big difference I think is that if you want to edit, like let's say you have a user and there's a file you want to change the permissions on it, depending on the data structure you're like implementing, this can be like really inefficient because it like go all the way through the data structure to find out like where the file is, then change that specific instance.
Right, so yeah, okay, so if I'm trying to change, so if I'm a user, right, well, okay. Inefficient if you think of it like a list like this, but you could think of this as a hash table, right, where like the name of the file maps to the permission, so it's basically a constant lookup, you could say. But yeah, then when you do change those permissions, you need to change the capability list of every single subject in your system, right, which could be a pain. How easy is it to, let's say, take away, so we didn't talk about this in the previous example, but now let's say I want to delete user P from my system, or subject P from my system. How do I do that here? Yeah.
Well, you'd have to go through all the other subjects and remove P from that list.
Here? Okay, so let's say they're not in the whatever the
Okay.
list. Yeah. We'll just keep it simple. So how would I do that here?
You just free the memory.
Yeah, and I just get rid of this list, right? Why does my pen keep going away? Right? I just delete this. Done. This process now has no permissions. It can't do anything on the system, even if it's somehow still running. In the other model, in an access control list, what happens if I delete user P? What happens? You have to go through every file and change every file, right? Okay. Okay, cool. So we've talked about this a little bit, and then so there's just a table that. So the other thing we can think about is the just the relation of. So we have our subjects, our objects, and so we can actually break apart each. So rather than thinking about it in terms of sets now, or we say object P has access F, read write, own, we can break it apart and just have a list or a table of all of the different access. So we can say subject P has write read on object F, and that's that line. And so we go through each of them to understand that they have read, write, and own, and yeah, read, write, and own on object F. Anyways, this can help think of it in a more granular level of kind of ripping apart rather than thinking about sets. Just think about it in terms of rights, or another way to think about it is in terms of permissions. This could be what permissions that like app A has Wi-Fi permissions, right? So you could think of like Android has something very similar to this for every app. Cool, okay. So, digging in a little bit more into the differences here between access control lists and capability lists. And we touched on some of these things, right? So we said that for access control lists, it must be the case that we can't alter the permissions, right? That a user can't just change the permissions of a file arbitrarily, right? So we don't want to store those permissions, let's say, on the top of the file, because that means if you have write permissions, you can just change permissions. What about in capability lists? What do I need to, we didn't talk about what I need to secure or keep secure here. Yeah. Yeah, I need to think about, well, where does this capability list live? So let's say if a process P just has memory in a fixed location that has this hash table in it, and the process itself is able to update it, that's probably a very bad idea, right? And we need to know, the other thing is we need to have a really good way of authenticating, well, how do we know that process P is actually process P and not something else? So being able to change, and especially when you think about it in terms of users, so that's one thing to think about. So this is so capabilities, they need to be unforgeable, right? So you can't say and just create new capabilities on the fly. That makes sense, right? The system must control that, in our case, the operating system. But what about propagation? What does that mean? Yeah, so great. So if a process, let's go with that. If a process spawns another process, what happens to those capabilities? Do they propagate to that new process? What if we would we ever want a model where, let's say, process P gives process Q write access to file F? Yeah, maybe, right? We may want it to do something on our behalf. We want the system to be able to control that, right? Of can a process or a subject just give permissions to another process? Like, how does that actually happen? So it's helpful then to think about that in terms of access control list versus capabilities. So, all right, cool. So this is actually just a graphical way of representing what we've been talking about. So in some sense, it's the same idea. Just to help clarify, capabilities are per subject, and access control lists are per object base. Cool. So one of the nice things we can get with, and again, so we're kind of splitting hairs here a little bit, because if you believe what I said, that a matrix, so we're just different ways of looking at an access control matrix, right? So it should be theoretically possible to do whatever you want in either of those two schemes. But as we saw, there's actually some natural either efficiencies. For instance, creating a file is much easier in an access control list model versus versus adding a user. So different ways have different things. Another way of thinking about is, we talked about this a little bit in terms of least privilege. So what's the concept of least privilege? We've talked about it in terms of policies and assurance, I think.
Only giving privileges, like the bare minimum privilege to get things done.
Right, so giving something just the bare privileges to get something done, right? So this means that Like on the submission server, like none of you should have root access to the submission server, right? If I did that, you could still submit your assignment, right? You could also do other stuff, right? You could see everyone else's assignment, do all this other stuff. You don't need to do that, so you have hopefully the least amount of privilege to submit your assignment and nothing more. So in this context, we can think that capability lists can provide a little bit more easily and more naturally some finer grained privilege. Specifically when we're talking, and this is somebody, I think it was over here, brought up the dynamic, like short-lived task. So you're creating a process or a subject that's going to be short-lived. It has a very limited set of capabilities that's much easier to do in a capability list model. And now, we're very close to that. Okay, cool. So, other things we didn't talk about. Trying to audit and say who has access to what is much easier in an access control list if we're talking about objects, right? If I have a super important file, right, that was like company secrets or trade secrets, and I wanted to say who has access to this, much easier in an access control list because I have the entire access control for every subject in the system. I can see who can read this file. Otherwise, I have to get it from every single subject in my file to see who has the capability to read this file. Does that make sense? Similarly, the other way around, asking what does employee X have access to is much easier in a capability system to answer because you have that set with the subject. Right? Again, different ways of looking at things. It's important to think about different types of trade-off. What about revocation? So we talked about that, touched on that a little bit of like deleting a subject. So revocation would be revoking somebody's access or access to something. Which way is better? In what circumstance is the real question. Yeah.
Capability was when you just look at the user and then just access the object and through the space.
Yeah, so it depends on what I'm trying to revoke, right? If I'm trying to revoke a specific subject's access to a file, that is much easier. You can also say that's easy, though, revoking that access in an access control list. So I can just go to that access control list on that file and remove that user's permissions. So yeah, it kind of depends, you know. It's kind of similar type of thing again. It depends on what you're trying to revoke. If you're trying to delete access to an object, that's access control lists are better there. Okay, so this is basically what we talked about here. Yeah. It's easy. Okay, so we talked about granting access. So depending on capability lists, we talked about that this can be easier of granting access to a file. But let's, rather than talk about so much theoretical stuff, let's actually look at the UNIX access control list so we can see how it operates, and it's a real system that hopefully all of you now use after assignment 1 or have touched or know how to touch. You'll get more familiar, I promise, as the semester goes on. Okay, cool. So how does the model work? Or how does, it's not a model now, how does the UNIX access control system, access control list work? I mean, first, it's a capability system or an access control system? Or access control list, sorry, I missed it. Access control list, how do you know?
Use ACL.
I mean, it uses the term ACL, and it's also on the slide. If you didn't know, how could you convince yourself?
Look at the source code.
You could look at the source code. Wow, very brave person. Not saying that you shouldn't or can't. Oh no. Okay, sorry, I can't make the font bigger, so I'm not sure of that. There we go. Can you see that in the back? Yeah, okay. So I'm just going to SSH to the submission server. Hopefully there should be nothing on there that's important. Okay. So I can do ls-la, which shows me all the permissions. It should show me the permissions of the file in the current directory. Is there anything important on here? No. Okay, good. Yeah. Secret. Okay, cool. So how do I know what the access control is for a specific file? Yeah.
You read like the DR, UNIX or stuff
Yeah.
on that side.
What is it? Explain it to me.
I think the R and the W is read and write.
Read and write? There's two of them though.
I think it's per user. Like I mean per group. So like one's for admins, one's for users, and one's for something else.
Okay, so I have a first one that does some stuff we'll talk about right now. We can see it's D on a directory and dash for not a directory. So there's some additional metadata about a directory or not. There's other bits in here which we'll talk about in a second. Read, write, execute. So the first 3 octet is the permissions to read, write, or execute this file by the owner. So that's the owner O. Then the next 3 are read, write, execute from the group. And the third is read, write, execute from everyone else. Or others, sorry, I think is the way it goes. Yeah, owner, group, other. Okay, is that it? Yeah.
Is that what the dashes signify, separating the owner?
The dash here? Yeah, the dash simplifies, so the way to read this, yes, the dash simplifies not like, there are no permissions. So for, let's see, this dot profile, the owner can read and write it, and the group can read it, and everyone else can read it. But how do I know what user is the owner and what user? Yeah.
Over one more column and say like U-2. I think if I remember correctly, that's the group, and the next one's user.
I think it's reverse, but I don't know how to prove it.
I think it's user.
I think it's user and group. I mean, right here we can't prove it, but I'm fairly confident it's user and group. So you have different files. So again, this makes sense, right? If you need to make an access control decision based on an access control list, if your bits are all about what the owner can do, the group can do, and everyone else, well, how do you know which of them? So you need to store additional metadata about who the user is and what the group is. Do you just store information about everyone else? No, that doesn't make sense. Okay, cool. So we have, and it's actually slightly more complicated than this. We'll go back to this because I like doing this. So there's actually, and you think about it, we only need a bit to represent each of those informations, right? So we have 3, we can use a bit for each. Read, write, execute for owner, 1 bit, right? Bits are really good at representing what?
True or false.
Yeah, true or false, 1 or 0, right? So read, write, execute owner, read, write, execute group, and read, write, execute everyone else. So why is there 4 of them? That seems dumb.
Or the SUID, GUID, and I forget what the third one is.
Yeah, so we have other 3 bits that do super important things that we need, and we'll go over those in a second. These are really important stuff, so, interesting, okay, cool. So we have set UID, set group ID, and a sticky bit. So this is very interesting. Then we have read, write, and execute. So let's go over quickly set UID, group ID. And let's dig in a little bit to this concept of, so we have the owner and the group of this file. Where's that information stored? Like, how do I know what users are on the system? EDC password / EDC PASSWD. Am I going to show you all my passwords if I do this?
No.
So we can look at this file. How do I know what user I am, besides looking at this bash prompt? Who am I, right? Tells me. The other one is ID, this is another good one. So it'll tell you the user ID you are, because again, this is a, it's not storing the file with string Ubuntu, it's storing a user ID that points to a user name, and that's how it's getting it all here. So I can see all the information about me. I have a user ID, a group ID, and I'm a member of several different groups. Cool. Okay, so actually, so can I read the EDC password file? Yes, why? How do you know that? Because it has a read bit on the last one. So am I root? Am I group root? No, I'm everyone else, right? So read, so I can read this file. So if I cat this file, will I be giving you all of my passwords? Are you sure? Do it. That's it. Okay. So, in this file, so this is on the Unix machine, it has every single user account. And so the way to read this file, it's not important of how to read this. So you can think of it as separated by colons. So the first one is the name of the user. The second one used to be a hash of the password. This is stored elsewhere, as we'll see in a bit. And then you have the user ID and the group ID of that user. Is this the group name, I think, here? Actually, don't know. And then the home location, so the home for root is /root. And then the last part is the shell of what shell to use. So we can see me, my user Ubuntu here, right? 1000, 1000, that matches with the user ID and the group ID that we saw when we ran ID. Okay. So, yeah.
So like, I see like above Ubuntu like colonn A, it says like 110 and then 1. So does that mean like 110 is the user ID and then 1 is a group? So there's something else in this list that has 1 as its user ID?
Yeah, I actually have no idea. I'm not sure what that column is. You'd have to. That's not what I want. Yeah, you'd have to look that up. I'm not 100% certain what this number is. I was just guessing based on what other stuff I saw.
Man5 gives you the format.
There we go. Thank you. Let's see. Login name, encrypted password, user ID, group ID. Yeah. And then username or comment field. That's weird. So you can have a username that's different from your login.
I think it shows up for finger output.
Jeez, okay. Wow. Okay, then home directory, cool. So the answer is yes, apparently. And then to see where the group is, there's EDC. There, okay, it's just group, right? Yeah. So you can then see EDC group is a lot simpler. So like, oh, so that was, you saw some of them were no group, some of them were one. Was that one we were looking at?
Yeah.
And that would be daemon group. See, learn something new every day. Okay, cool. So, yes.
Why is Linux like a shitty bud as opposed to having like an intuitive file system where you can get all those commands you can actually like say like, oh, I want to see this, I want to see that, as opposed to having to memorize a million different commands.
I mean, do you want the historical answer, or you want the like, why do we still use it?
Like 30 years and then later, yeah.
I classify it, if you take like an HCI class, they talk about like expert interfaces. So like Unix is very much an expert interface where it's very difficult to get started, but as you master like more and more of these commands, you can actually be much more efficient than people poking around with a GUI on like many different things. So the interesting thing to think about is like Windows Land came up with like PowerShell to do command line type stuff in a nice way, and composing all these commands, doing all this stuff, you can do a lot with what seems to be very little. But yes, it has a lot of UX problems in terms of discoverability and figuring out how to poke through all these things. Okay, cool. So the example I like to give. So we have this file here, right? The EDC password file. Can I write to this file? No. If I can write to this file, what can I do? I can change users. I can change my user to user ID 0, which would be the same as root. So the program, the operating system would think that I have root privileges, which means I can do anything on the system. I can change logins. I can add another login, right? I can do a lot of things. I can basically take over the entire system by editing this file. So should you allow users to edit this file? But the last field here is what? What did I say it was? The very last one. What's this last part? Somebody just said it.
Shell.
The shell? Yeah, so this is when you log in, what shell do you use? Right? Well, I don't want to use bin bash. I want to use something else. So how do I change it? Do I like do vim etc password? And then I go down to let's say sh, because I'm very old school. Why can't I write this? I don't have the right permissions to this. So how the heck can I change my shell? Let's say I'm not a sudo user though. I am on this, but even if I'm not, I still should be able to change my shell. That's my shell that logs in, that gets set when I log in. Yeah.
I think you can do that in your profile. You may not be able to.
Do you have a user local etc password?
You do not have a user local etc password. It turns out there's a nice command called change shell, CHSH, change login shell. So shall we do that? Oh, but I don't know the password of this account.
Can't we just find it? Oh wait, never mind.
Okay, I'm going to run this as sudo, but look the other way. Pretend I do have a password. This is only because I literally don't know the password to this Ubuntu account. It was created automatically by Amazon. I don't know what this password is. But I can run it as sudo, but that'll change the login shell for root, user. No, okay, so it's saying, the login is the second parameter, okay. Okay, so I want to change it to bin sh. You tried typing in front of 200 people. Okay. So now what do we expect to have changed to etc password?
The extension on Ubuntu.
Yeah, so it should be that Ubuntu changed to bin sh. How did this happen? We just saw, as the Ubuntu user, I cannot write to that file. How did that file just get changed? Pretend I did not type in sudo. That does not matter here at all, I promise. Yeah.
I'm gonna guess that you asked root to change it for you.
Yeah, so in some sense, I can't run it, but we somehow need to ask root to change it for us. So how do we do that? So I can do which chsh. I can do ls-la. Say, what the heck is this change shell password? Why does this look different? It has an S instead of an X for the user. Right? Remember there was those three first bits, set UID, set group ID, and a sticky bit? So set user ID, and that's why that's super annoying. Is that thing moving? Anyways, okay. So you also see that the shell changes the color of this in red to indicate. So there's an S here. This means it's executable, and its set user ID bit is set. What this means is when this process executes, rather than have that process execute as the user who executed that, basically means execute it as root. So let's, we can actually verify this really quickly. Normally I'd use something like a terminal, but whatever. Okay. Sage software on my system. Yeah. Okay. So I can run cat. What's the user cat running as? That was funny. So I can see that cat, right? The program cat, process cat is running as user Ubuntu, right? It makes sense. I'm logged in as user Ubuntu. And in fact, if we look at everything that's running on our system, will this tell you any information? I hope not. Tree. So you can see there's actually a ton of stuff going on this server. We have a RabbitMQ that's storing all your jobs, a MySQL server, the Apache server. Okay, there we go. So I can see actually, so if you ever wondered what happens, how you get onto a remote system, so you have the SSH daemon that's listening, running as root. I've logged in, and once I logged in, it gives me a terminal where now it knows I logged in as the user Ubuntu. It gives me a terminal that's running as Ubuntu, which then runs bash, which was my default shell, which then now this is what I'm literally looking at right here. This is the process that's running HTOP. This is the process number, and I have bash and cat. Okay, the whole reason we're doing this is so I can see that cat is running in my other terminal with the same user as Ubuntu. Now, if I did user bin chsh, now if I look, I can see that that is running as root, right? Change shell is running as root because of that set UID bit is set. And this is how the CSH program is able to change a file that should only be writable by root. That make sense? This is how it all works. There's nothing magic here. And so set group ID works similarly to set user ID, just now with the group. So it will run as whatever group you have that set as. The sticky bit is very complicated. I can't remember off the top of my head. I think it's set user ID. Do you remember?
It's file permissions in a directory you don't own. I don't remember what the...
Yeah, it allows you, I think, to create files in that directory, but not do other stuff. Also, what does it mean? So we just went over what all these things mean with files, right? It's pretty easy, read, write, execute. What about for directories? What does it mean to read a directory? You can list the files that are in that directory. What about write to a directory? I think it means you can delete files in the directory, assuming you have permissions to, and create new ones, I think, in that directory. What about execute? Does it make sense to execute a directory? Yeah, but maybe that's the same thing as reading. So the interesting thing is, so execute means that you can go into a subfolder of that directory, but you may not be able to list it or create files. So, and other things are, I think, is SynCode mean anything there? I don't think so in a directory. Anyways, the important thing is directories are slightly different, but we can see this access control model, right? We can see the access control list here. We know the permissions that are here, the user ID, the group ID, and we can see how the operating system is putting this all together in order to do the access control checks. Cool. All right, awesome.